For a long time, we have romanticized the idea of living on another planet like Mars or Proxima B. And we have always been infatuated with the possibility of the existence of extraterrestrial lifeforms far more advanced than us. But until now, it has always seemed far-fetched for a number of reasons. However, where there is water, there is life. The Curiosity rover recently sent back data that supports the existence of large water-rich bodies on Mars and potentially life. Join us on our voyage to the Red Planet as we search for water and knowledge aboard the Curiosity rover. It promises to be thirst-quenching. There are plenty of reasons why no one should want to live on Mars. With very cold temperatures, an unbreathable atmosphere, toxic soil, and a host of other reasons, the planet is just downright inhospitable to life as we know it. Or so we thought. NASA has carried out several investigations and experiments on this seemingly barren planet, one of which has led to a fantastic discovery that could lead to a complete turnaround as to how we see the Red Planet. Using rovers like Spirit and Opportunity, Sojourner, Curiosity, and Perseverance, NASA has discovered that Mars had a warmer climate, ancient volcanoes, a watery past, and past signs of flowing water. Now, Curiosity may have just found the right conditions for life, so maybe this planet is not so bad after all. Each of the Mars rovers was designed to be the mechanical representation of a geologist. Their high, mast-mounted cameras offer two-eyed, 360-degree views of the landscape. And their robotic arms, moving just like human arms, complete with elbow and wrist joints, can place instruments on interesting rocks and soil targets in order to obtain data. A tiny camera that serves the same purpose as a geologist's handheld magnifying lens is held in the mechanical hand of the robotic arm, and the rock abrasion tool reveals the inside of rocks just like a geologist's rock hammer would. Our thirst to explain the unknown and discover the undiscovered knows no limits. That's why NASA sent out Curiosity rover, a 1,982-pound or 899-kilogram mobile laboratory to the Gale crater. The rover was launched on November 26, 2011 from Cape Canaveral on the Atlas V 541 rocket, and after almost an entire year traveling through space, it landed on Mars on August 26, 2012, beginning its first drive 23 days later. The SUV-sized rover is about as tall as LeBron James and uses a 7-foot or 2-meter robotic arm in order to study rocks of particular interest. Curiosity's 6-wheeled rocker bogie suspension system allows it to move at speeds up to 295 feet or 90 meters per hour. The rover is powered by a radioisotope power system that uses the heat produced by the radioactive decay of plutonium. Because the Martian atmosphere is too thin for conventional aerobraking and parachutes, yet too thick for rocket deceleration, Curiosity employed a special EDL, or Entry, Descent, and Landing Procedure. The rover's comparatively heavy weight, which is heavier than anything that has ever touched down on Mars before, posed significant engineering difficulties. The EDL featured 4 distinct phases: guided entry, powered entry, parachute drop, and sky crane landing. And most incredibly, Curiosity completed this EDL procedure completely autonomously, without any interference from the mission team. To communicate effectively with Earth, Curiosity is completely reliant on a sort of walkie-talkie system with the Mars Odyssey and Mars Reconnaissance orbiters. With an estimated cost of over $1 billion, NASA's Curiosity is the largest and most advanced rover ever sent to Mars. It carries the most sophisticated equipment, which it uses to study the origin, structure, and chemical makeup of Martian dirt and rocks in its tireless quest to discover the chemical components of life. As contribution to NASA's Mars exploration program, Curiosity has 4 primary scientific objectives: ascertain whether life has ever existed on Mars, give an overview of Mars' climate, describe the features of Mars geology, and prepare for a human expedition. The Curiosity rover did not waste much time showing its capability. By September of 2012, just barely 1 month into its mission, it was already producing great results. On September 27, 2012, NASA said that Curiosity had discovered signs of an old steam bed, suggesting that there may have previously been a vigorous flow of water on Mars. NASA released the findings of Curiosity's first in-depth soil investigation on December 3rd, showing that water molecules, sulfur, and chlorine were present. More definitively, NASA declared in March of 2013 that findings from the rover, based on an examination of a rock known as John Klein, named for a former principal investigator for the mission, revealed that Gale Crater was once a favorable environment for microbial life. Additional research revealed the presence of hydrogen sulfide, carbon dioxide, sulfur dioxide, and water. In the following months, Curiosity sent back some breathtaking photographs, one of which showed Earth in the Martian night sky. In another spectacular photo taken in April of 2014, the dwarf planet Ceres and the enormous asteroid Vesta were visible. On August 5, 2014, Curiosity reached the 2-year mark on Mars and had already surpassed its initial goals. The mission's most astounding news may have come on December 16, 2014, when NASA researchers revealed that Curiosity had successfully located the planet's first instance of organic compounds. These were discovered in a sheepbed mudstone drill sample from Gale Crater. The sample also contained clay minerals and not a lot of salt, indicating that the area formerly had fresh, drinkable water flowing through it. Later, in March 2015, researchers revealed for the first time sample analysis data that showed the presence of nitrogen on Mars' surface, released during the heating of Martian soil. This was an enormous discovery, as nitrogen is an essential element for life, responsible for building DNA and RNA, and for protein coding. The nitrogen found was in the form of nitric oxide, perhaps formed from the decomposition of nitrates. NASA referred to this kind of nitrogen as biologically beneficial, and the findings strengthened the claim that ancient Mars may have previously been habitable for life. In October 2015, Curiosity's findings proved that Mars had had lakes of water. According to research, the mountain in the center of Gale Crater, Mount Sharp, was built on layers of material that were deposited into the crater with the assistance of water. As of August 2, 2022, Curiosity had traveled 17.64 miles, or 28.39 kilometers, and the discoveries have only continued. At this point, you probably have a lot of questions, like why did NASA choose the Gale Crater? Well, everything had been building up to this historic moment. The Gale Crater was formed when a meteor hit Mars about 3.5 to 3.8 billion years ago. The impact from the meteor punched a hole in the terrain, and the resulting explosion ejected rocks and soil that landed around the crater. Scientists chose Gale Crater as the landing site for Curiosity because it has many signs that water was present over the course of its history. Gale Crater is continually being bombarded by powerful radiation because of Mars' thin atmosphere. However, the underground fissures offer a much more protected habitat that is better shielded from that radiation. Within these fissures, Scientists, with the help of the Curiosity rover, have discovered the presence of large amounts of water-rich opal. At the poles of Mars, water ice is abundant, but not at the equator, where Gale Crater is located. A research team had previously transmitted and evaluated data from the Dynamic Albedo of Neutrons spectrometer on board NASA's Curiosity Mars rover. They discovered fracture halos, rings of light color silt that stood out in photographs taken by Curiosity due to their unusual color. Subsequent analysis revealed that the light rock was indeed opal. The presence of opal suggests that Mars may have dried up after the formation of the fracture halos, which were some of the last locations on the planet where there was a lot of liquid water. A combination of silica and water is what helps to generate opals. On Earth, similar solutions may be found in hot springs, geysers, the ocean floor, and other bodies of water. Silica particles start to form an opal when they sink to the bottom of the fluid. Yet because opals are what is referred to as an amorphous mineraloid, it is feasible to reverse this process and actually extract water from them. Opal's crystalline structure is less securely bonded than that of true minerals, which allows water to be drawn out of them. If more opal can be discovered, astronauts exploring Mars in the future may have a large water source in fracture halos. All you have to do to get the opal to release water is boil it up and crush it down. It is estimated that 1 to 1.5 gallons, or 3.8 to 5.7 liters, of water might be stored in the top 1 foot, or 0.3 meters, of the surface of a fracture halo with a diameter of 1 meter. Thanks to the amazing discoveries of Curiosity, the Perseverance rover now has a new emphasis for its own mission. If opal-containing fracture halos are found in Gale Crater, they could also be found in Jezero Crater, where Perseverance is looking for evidence of previous life. In fact, this possibility is thought to be quite likely, as Jezero Crater's former status as a lake has already been well established. With this latest discovery, do you think we'll see a crewed mission to Mars sooner than expected? Let us know in the comments.